Okay. Alrighty, so you should actually hear me through that. Hopefully it's not too muffled. We are going to do our lab 4, which is your copper sulfate pentahydrate. The name itself is just scary, right? All that means, it's a copper sulfate molecule that's surrounded by waters. That's it, okay? So the whole purpose of the lab, let's go ahead and talk about the purpose first of the lab. The purpose is to make a solution, okay? Want to learn how to make a solution in the lab because this is science. The next thing is we are going to use that solution and dilute it and do several different dilutions from the darkest of the dark blue to the water. So dark, slightly dark, light, 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 light blue, lightest blue, water. And we're going to have several different dilutions of that with darkness. I already said with darkness. Okay, move it on. So I'm looking at your lab right now. There we go. Safety note. Very important safety note. Always look at your lab's 4 safety note. It says, never pipette by mouth. Well, you know, we ain't doing anything by mouth with these masks on. But once upon a time, a long, long time ago, in laboratories, they used to mouth pipette. Oh my gosh. How crazy are those individuals at that time? That's all they had to do. But we have these plungers here. These are plastic, so it's not much of an issue, but you ease in. Because we have not done the lab beforehand, did you remember seeing this piece in the lab beforehand? I'm going to just show you how to read it, okay? As you read it, when you look at this is called a, not a measuring pipette, serological pipette. So when you look at it, you see the number 4, or at least on mine you do. You might find you have, yeah, good. These are all good. If you find that it's not it, then I'll let you know. So, I mean, then you can let me know and I'll explain it to you. So if you want 1 milliliter, you take your liquid up to the number 4. If you want 2 milliliters, you take your liquid up to the number 3, right? So you're going from the bottom up. If you want 5 milliliters, just count it up. 1, 2, 3, 4, and 5. You could even see the small numbers on over here. They're cheating numbers. But sometimes they don't have the cheating numbers. So some of you guys might have cheating ones, some of you guys might not. So I'm just explaining it. That's how it goes. Alrighty. If you have glass ones, I'm assuming that you all have plastic, but I'm not going to. Please be careful easing them in and out because they will break if they're glass. Alrighty. So never pipette by mouth. Also, wear safety glasses in all your buckets. Oh, I'm so sorry. I have your stuff over here. I'm showing you. Can you see well? In all your buckets, you have safety glasses. Before you put them on, I highly suggest clean them with some Lysol. I'm pretty sure you're about the first or second labs of the week, but maybe. So hold off on that. We'll do it. I'll let you guys go. In the end, you can do all that. So the other thing is working and using whenever you're using the chemicals, if you have chemicals on your table, you have to be wearing gloves and goggles. There's no getting away from that, okay? I'll pass these out where you can grab them here pretty soon. Alrighty, so there's your big safety notes. Post-lab cleanup. So in the post-lab cleanup, you're gonna put all your blue juice. The blue juice is copper sulfate pentahydrate. It's not Kool-Aid, okay? Don't get it on your fingers, don't get it on your clothes, wash your hands. It will stain your clothes, so if you got nice clothes, just be careful. Here's your waste. You will empty everything. If it's blue, it goes in here. I'm probably yelling too loud for my mic. So if it's blue, it goes in here. And then once you kind of got all the drops out, then we can wash it in the sink with soap and water, even if it has a smidgen of blue. Just do what you can, okay? Remember, you're wearing gloves. Alrighty. So, understanding. The purpose is also to understand molar mass. So this usually takes a while to calculate. Now, I'm going to go home and I'm going to make you guys a video on how to calculate the molar mass because you will be expected to know how to calculate molar mass for your lab practical. Okay? So if you need more examples, hey, Ms. Aragon, send me another example. Right? I'll also give you some example sheets if you need me to find more videos, whatever, working through. Okay? But I'm not going to do it here. I'm just going to give you the answer here. So I'm looking on the very next page, working on page 2. about molar mass. I'm going to give you a little quick note. You're like, what the heck is molar mass? I'll tell you what it is. Your molar mass is a measurement of how many molecules in a solution. That's really what it is. Okay? So when we're trying to figure out, if you look at these, where are we? When you look at this, oh, I don't think you're supposed to know that because it's unknown. It says 0.233 moles of copper sulfate pentahydrate. That means it's telling you how many molecules per liquid of solution. Yes? Yeah? No, it's the same thing. It's just stated differently. Yeah, you're gonna find they're gonna give you way more information than what we give you, because we give you what you need to get by, because we're biology. You just need this much chemistry, but chemistry they're gonna give you a lot more details. Yeah, so you're good. You're great. Alrighty. All right, so la di da di da di da. I'm passing the calculations. I'm looking on page 2, and on page 2. Oh, sorry. I don't want to do page 2. I want to go forward more. Page 3, highlighted towards the bottom, says how many grams will you need for the solution? You will need 5 grams, 5.0. Did you already do the calculations? Hot damn. All right, it's up 4.99, but I rounded it to 5.0 because I'm not sure how your balances are. Your electronic balances, depending on your electronic balance, it might not measure out 4.99. So that's why we do 5.0. All righty. So write that answer in there, and I will do a video later on how I came up with that answer. Moving on. So that was on page 3 where it's highlighted and it says how many grams will you need? You will need 5.0 grams of copper sulfate pentahydrate. I want you to add that. Where's all my markers? There we go. How about I just go like this? 5.0 grams CuSo4. Why did I need to put this? It's really important. Why is it important to put that? Oh, I'm not done. All right. Why do I need this label? How else am I supposed to know what to put in it? Right? It could be 5 grams of sugar. It could be 5 grams of boogers. I like boogers. I talk about boogers sometimes, okay? I don't really like boogers, but I just like gross stuff, and to me that grosses people out, so I talk about it. So you always have a label. So make sure, are y'all listening? On your lab practical, when you do your calculations, or anything you turn into me, always have a label. Okay, especially on on that lab practical, because otherwise it's wrong. Alrighty. So your next page, page 4, has a bunch of complicated talk about Beer-Lambert law and light and blah-de-blah-de-blah. Who would like me to explain it simplified? What we're going to be doing with this? Nobody? Okay, well, I'll just pass it then. I'm just joking. Okay, so have you ever gone outside in the hot, hot sun and worn a black shirt? Yeah. How'd you feel about that? You're hot. Okay, so what about wearing a white shirt? You feel less hot. Okay, so the pigments in the shirt, the dark pigments, have a greater capacity to absorb energy. And the energy when you're outside is solar energy. So the dark pigments have a greater capacity to absorb solar energy versus the lighter pigments. Okay, so we're not going to be doing solar energy, but what we're going to be doing is other light energy, and it's going to be through our colorimeter. This colorimeter is going to pass light. Yeah, see, somebody left a specimen in there. Don't leave specimens in there. That's naughty. Okay, they're going to pass light through your specimen. That's water. How's the pigments in this? Non-existent. So what do you think? Is it going to absorb the light energy? Nope. And if it doesn't absorb it, it's going to transmit it. It does the opposite. This is going to have a great transmittance, or transmission, well, it's just about the same, but not absorption. So when we make our blue juice and we have the bluest of the bluest juice, would you expect a dark, dark blue juice to absorb a lot of the light? Yeah, that's what we're going to illustrate today. That's the whole point of the lab, is to illustrate that. All right, but here's the deal. We got to make the blue juice first, and that's half the complicated thing. So here's what I'm going to tell you to do. I'm sliding down, preparing standard solution. I'm looking at page 5. Page 5. I know I said I needed your toys, but then it turned out I did not need your toys. This is your heating hot plate, okay? Looks like a little toy or something like that with googly eyes. But this is your hot plate. Everybody's got a hot plate on their desk. Some got big ones, some have little ones. One of these is heat. So confirm the one on the left is heat. Yep. What about the big ones? I'm not familiar with the big ones. All right, so this is heat, and this one is stir. Okay, so the heat is really important to control. It's going to be controlled at 40 degrees Celsius. I'm going from memory here. Oh, I know that's what I know I'm pretty right. If I have to correct it later, but I'm pretty sure I won't. All right, 40 degrees Celsius. The stir, the big ones, oh, those look pretty powerful. I'm not sure. I haven't used those ones yet. I've always used these small ones, okay? The small ones, you're probably going to put the stir in about a number 3 or 4. 4 might make your beaker shake. 3, probably about just right. But just as long as it's moving, but your beaker's not shaking. I'm not sure. We're going to have to play with those big ones and see what happens with those big ones. You're like, what am I stirring exactly? So let me show you what you are stirring. You're going to prepare yourself a beaker. Now this is ultra important, and I need you to double check and triple check that you are using a 50 milliliter beaker. That's the tiniest one. Your instincts are to go to the big one. This is 100 milliliter. You need to be using this one, the 50 milliliter beaker. And the reason why, I might not have any stirs. There it is. Here's the stir, just like such, okay? This magnetized. So when we turn on the stir, it's going to have this go around, and by putting it in the small beaker, it can grab on the corners, right? So it's really important that you do that. If you use this one, you're probably going to have to start over, so don't. Okay. All right, so you're going to do the beaker. I'm looking at number 1, put on gloves. Number 2, after you calculate, we already did how much we were going to calculate. So let's go ahead and put number 1, our stir in the beaker. What happened to my black? There we go. Put the stir in the beaker. That's my stir. Then you're going to put 5.0 grams of copper sulfate pentahydrate. There you go. 5.0 grams CuSo4 5H2O into the beaker. That's what all of this is. The blue crystals. So as you're looking here, here's your blue crystals right here. Copper sulfate pentahydrate. All righty, you're going to get your graduated cylinder. 18 milliliters of DI water. Okay, 18. So here's your graduated cylinder. Make sure you are aware of all of your different equipment, because that will be on the lab practical. Oh, by the way, I always tell you what's on the lab practical. Isn't that nice of me? So, graduated cylinder. You're going to pour that into here, okay? Ooh, there you go. You're going to run this. You're going to heat it to 40 degrees Celsius. Now, these ones here actually have 40. Those ones don't, right? Do they just have a number 4, Andrew? All right, number 4. Can you guys see what I'm doing here in the camera? In the camera. Like over here. Am I recording this? Okay, just making sure. I just don't want to waste that. All righty. So anyway, for about, I'm going to say 25 to 30 minutes. So it says 30 to 40 on there, but I've done this a lot, and I know how long it's really going to take. It's probably going to be 25 to 30 minutes. Okay. Now, what you're going to do is watch it. If you take your eye on it, so you guys are partners, Sandy and Amy. Yeah, get it? Oh, not Sandy. Sandra? Sarah, shit. I'm sorry. I'm a cusser too. So anyway, Sarah and Amy, if you're working, she's watching. If you're working, she's watching. Okay, you only have 2 people per group. So you need to coordinate that, because I've had this happen at least one time every semester, except for the last 2 semesters, because people really believe me to watch. If you don't watch this and it gets too hot and it's not stirring enough, boom, it solidifies and you got to start over. Okay? Yeah, you don't want that. You definitely don't want that. So make sure somebody's watching at all times. Alrighty. So the next thing is you're going to go ahead and heat that. Before you pull it out to move on, call me over so I can look at it to double check that it's ready. Because sometimes you're like, oh, I know it's ready. And I look at it, I'm like, nope, you can see little particles still. Okay? So call me over before you do the next thing. When I tell you that we can go ahead and move on, you're going to remove it from the heat. Okay? You're going to go ahead and pour it in to the graduated cylinder. And it's probably going to be down here. Let's put some blue on that blue juice. There's now blue juice. I don't know what it's going to be. Maybe it's 17. I don't want to give you a number. But what you're going to do is you're going to catch it up to 20 milliliters of DiH2O. I'm not telling you to add 20 milliliters. What I'm telling you is add DiH2O until the level reaches to 20. You guys get that? So if this is at 17, catch it up to 20. If this is at 16, catch it up to 20. That's all I'm trying to tell you. Alrighty. So once you got that, I'm now looking at page 6, just kind of going through if you need to follow with me. This is very important. Once this is done, pour it back into the beaker. Whoa. Now, you are ready to start. Now you're ready to start. Do not draw from here. You must put it back into the beaker, because accidents happen so much when you're over here trying to figure out how to get this out of here, and then you're knocking it over. So you pour it back into the beaker. Alrighty. So there's that. Now, I'm going to need to erase this. Did you guys get all your good pictures drawn? Yeah? Oh, you better draw it. I'm going to start talking about other things while you finish drawing that. You can take a picture if you want. I will have this video available for you guys too, if you want to look back. All right? Okay, so with that, the next thing you're... Oh, wait. I'll have this video available for you. You guys can screenshot it, so it'll be all good. So you are going to take this, ready to start, and you're going to need to dilute it. So, you would think that I'd learn. And if you recall, what is in this beaker? We put in 5 grams of copper sulfate pentahydrate, and we mixed it with water. But if you read in your reading, what really happened is you made a 1 molar solution of copper sulfate pentahydrate. And when we talk about 1 molar solution, I'm going to write down molarity so you can see. Molarity is equal to the... I got to think about it. It's been a while. Shit. I'm having a brain fart. Liters. Moles per liter. Thank you so much. Huge brain fart. And you're like, well, what are moles? Well, we're going to learn about moles being equivalent to how many molecules. Okay? All right. Liter per the total water. This is scary. That's why I just give this for now. Even in my regular class, I never do the whole calculation in class. We don't have time for that anyway. So you have made a 1 molar, right? Molarity, 1 molar solution of copper sulfate, CuSo4, 5H2O. Now, We've got to dilute it. What does it mean to dilute? Just make, yes, you just make several different concentrations of it. Okay? So we're going to have test tubes. Should be 1 through 7 or 1 through 8? 1 through 8. There we go. So I'm going to go dot, 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 dot. And here's number 8. So 1, 2, 3, 4, dot, 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 number 8. So your first, I'm looking at page 6. And I'm looking at the table 1. Page 6 on table 1. Do you guys see where we are? That's how you're going to do your dilutions. Okay? If you look at test tube number 1, test tube number 1 has 0 milliliters of the copper sulfate pentahydrate. And it has 5 milliliters of DI water. So that means it doesn't get the blue juice, but it's going to get all water. Okay? So black equals water. I'll just go ahead and put H2O. DI, that just means that it is deionized water. It comes from the deionized faucet. Alrighty, so here's the thing. You'll read in here that all of these are going to have a total of 5 milliliters. All have total 5 milliliters. Okay, so this gets 5 milliliters of water. Look at the next one. Oh my gosh, it's blank. That's where your math comes in. We're going to figure it out. I'm going to show you how to figure it out in a second. Let's go to an easy one first so you can just at least feel good. Number 8. Number 8 gets 5 milliliters of copper sulfate pentahydrate, 0 milliliters of water. Boom. Just like such. So am I still recording? I'm just making sure. I just don't want to go through this. This is really hard. This is a damn workout up here. Trying to breathe and talk. So this has 5 milliliters of the 1 molar solution. This has 5 milliliters of 0 molar solution. Do you see that on your chart? We have to figure out everything in between. It's not terrible. I'm going to show you how. Okay? Take a peek. I need to erase at least that over there. So, if we're starting, I'm going to put it over here. Remember, we have a bank over here that's a 1 molar solution. And we put it however much we need. Boom. So we need to figure out what's in here, what's in here, what's in here. So your first one, I'm going to go ahead and do test tube 1, test tube 2, test tube 3. I'm just doing your little chart. Test tube 4. Okay. This was water. No. 1 molar CuSo4, right? This is H2O. And this is molarity of solution. So we need to figure out how much we put in each. So if this is 0 and this is 5, that's a 0 molar solution, right? Okay, so we're going to have to do some calculations. So the calculations are going to begin. I'll do it a little bit lower here. I like to use, if you slide up, it says V1 M1 equals V2 M2. Do you guys see that up on the page a little bit higher? Okay. Rather than saying 1 and 2, I am in the habit of saying initial and final. That just means something to me. I don't know. It speaks to me more. It's all the same thing. But so the volume initial times the molarity initial equals the volume final times the molarity final. Okay? So with that, it was real easy. We can figure out the molarity final because the chart gives it to us. It tells us. It wants this one as a 0.1. It wants this one as a 0.2. It wants number 4 as a 0.3. There we go. I'm not going to finish the chart because I need room. Alrighty, so I'm going to go ahead and do that one. Let's go ahead and plug this one in. I'm going to work on figuring out what to put into test tube number 2. I do know the molarity final, so let's plug it in. 0.1 molar CuSo4 5H2O. I'll do that sideways. There we go. That way. Alrighty. Can you see that in my camera? All right. Thank you for checking on me. I appreciate that. Final volume. Now, what did I tell you the final volume is going to be on all of them? 5. They're all going to be 5 milliliters. Right? Final volume, 5 milliliters. Boom. Okay? Boom. Molarity initial. What did I put in there to get started? A 1 molar solution. That's it, right there. The molarity, it's that, not even, don't try to make it harder than it is. So 1 molar CuSo4, 5H2O. I never leave enough room. Boom. I'm just going to put Cu solution. There, I can fit that in there. Copper solution. What's the last variable? Volume initial. I need to figure out how much of that do I put in here? How much of that do I put in here? I don't know. That's the calculation we're trying to figure out. How much of that I put right here. Boop, 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 boop. All right, so go ahead and start your calculation. I'll catch up to you and you guys see. Why don't you see if you get it? I'm going to put volume initial. Sometimes people don't like my math because I do things a long way. Why do I do things a long way? Because I taught many a chemistry class, many a physics class that made me do it the long way. So I passed on the love right to you guys. Why? Because it makes a difference between getting a D and an F and getting an A. Because unfortunately, you get to a higher level of science where you can't really guess. Sometimes you can guess and get it right, but are you able to apply that to harder questions? Yeah. Alrighty. So, I'll show you my calculation. This is how I get it done. Hopefully I can get that in here. I need to isolate this variable. Divide it by this. 1 molar copper solution. Right? Cancel, cancel. I forgot the equal sign, my bad. Whatever I do to this side of the equal sign, I have to do to that side of the equal sign. Divide it by 1 molar CuSo4 solution. Boom. Now my variable is left alone by itself. I'm just gonna equal sign it over here. So I'm going to go volume initial equals, I'll still rewrite it out since it's kind of sloppy, 5 milliliters, and then times 0.1 molar copper solution. They do that in chemistry, they get your, and then you have a 1 molar copper solution. All right, so this is what's important, and this is why I wanted you guys to learn dimensional analysis. And people fight me all the time, and I'm okay, I don't take offense to it. But we have to chase labels, okay? So we can't just decide, I'm going to decide as milliliters. No, we have to make sure we are canceling labels. So what we can cancel here is molar CuSo4 solution, molar CuSo4 solution. Let me use purple. Cancel the label. Cancel the label. Now that label's bye-bye. Now you're left with the label that you need, milliliters. Does that make sense? So the numbers are important, but the labels are so important. Because if you don't cancel labels, sometimes we just do the work in our head, but we're not working the process right, and you end up working it backwards or sideways or wrong. All righty. So what's my final answer, my friends? What did you come up with? You got it. Of what? CuSo4 solution. I know, I tricked you. Sorry. CuSo4 5H2O. Boom. Alrighty, there you go. So you just do that calculation for all of them. So right here, 0.5 CuSo4 5H2O. It's already labeled up here, so it's good. Okay. How much is here? How much water? So that's how much I put here. How much water do I put in it? 4.5. You got it. 4.5. Because you need, so this is going to be 0.5. This is going to be 4.5 to make a total of 5 milliliters. Just do that for every single one. So your objective is to, that doesn't mean jump up and start working because I got to, actually I probably will and then I'll explain the next piece in a different piece. Okay. Your objective is to make your solution. While your solution's sitting there for the 30 minutes, do your calculations, prepare all of your test tubes. Okay. You can write the test tube on there. I don't have any markers, wax pencils, so I will get you some. Okay, I'm not gonna get. Well, I could get you Sharpies too. Sharpies will work just fine. Prepare all your stuff. Once you got your calculations done, let me know. I want to check them, and then once I've checked them, you can at least be putting your water in. Once you figure out how much water needs to go in. Does that make sense? That is your objective. I'm going to call everybody back because have I illustrated anything about light and absorbance? No, we just have to make the solution first. Okay. You should have your solution made in 10 minutes. You're like, what? All you got to do is one person go measure it out. There's electronic balances. Hang on.